This conference will now be recorded.
Do you think we can? Sunidhi, is it possible that we can? No, we cannot. That's not possible. Can we use C code in Python? Can we use Java code in Python? No, actually. We would require some external help if we really want to do that. We can have some functionality from it, but we cannot directly use it. So yeah, R can also solve the same problem. It is more towards the statistical, tools, as we say. But Python is more emerging and it's been more used in the industry and libraries also. Yeah, anybody have any questions before we start so that we can start it? Nobody have any questions? Okay, great. So today we will be talking about the neural networks. So let's see. So how did neural networks came into picture? So neural network, the desire for the neural network was, or the need for the neural network was to understand how our brain works. It took the inspiration from our brain, and we thought of building something that we can replicate our brain, and then maybe we'll be able to understand our brain, better to in a better way. Basically, how does it works? All the functionality of our brain. That's what we were trying to do with the help of neural networks. Because might be we have lots of computing power, we are very good at programming, we are able to recognize things, but still we are failing at a particular task, very simple task, which was recognizing which is a cat, which is a dog. So that was the problem we were facing. Then that is the reason we thought of, can we build something with which we are able to recognize dogs and cat, and the easy tasks that we are not able to with our regular coding. If we are able to understand our brain, then maybe we are able to solve this problem, and maybe then we are able to recognize different objects, and we are able to solve problem related to computer vision and all. Because as per the Moore's law, the number of transistor on the integrated circuits has been increasing, and the ICs has been decreasing in size. I mean, now we have lots of computer powers. We have good computer power. We have good computers to use. That means this task that we had for recognizing the dog and cat, it should be very easy, right, with programming. But it was actually not. That means because for any program to work on, we need to write. If I want to solve this particular problem just by doing some programming, then I have to write if and else statement. If this is the case, do this. If this is the case, 2, do that. If this is the case, 3, do that, and so on. Of course, the for loop and if and else statement, they are very amazing to solve certain tasks. But solving a task related to recognizing cat and dog, I guess that would not possible when we talk about for loop if else statement. That was not possible. How many for loop if else statement we will write in solving any sort of problem? Maybe for the next day, I might need to recognize something else. You know, maybe something else could be a male or female. Then I would go back again and I will write another set of rules for it. So that was not a solution basically. Then we thought of understanding our brain. How does our brain work? How does the neural neurons that we have in our brain, how does they work? Let's try to understand them. Let's look at the, we have billions, tens and billions of neurons in our brain that constitute our brain. This many amount of neurons we have in our brain. For each and every smaller task, if I say for my new task, you have a neuron in your brain which is doing that particular task. So let's look at the semantic. This is how the semantic of a neuron looks like. It has a body, it has a starting point, it has some ending point. It's for the input, it's for the output, and then there is some processing going on here. So yeah, this is called the dendroid, wherein we receive the inputs. Whenever we do something, we receive the input, it comes through the dendroid. Then I have a body as well. Then I have axons, which is the output. So how is the input? Let's try to understand how does the input get transmitted from the dendroids to the axons. So if I have a certain amount of input, it will go to this part basically. There is some which we call as a cell body. There is some sort of processing happens here, and if that input is to the amount which this cell body was looking for, then it will pass that information to the output. So what do I mean by some processing? What is that processing? So that means I have a certain threshold value which is set for the input, that if my cell body receive the threshold value, a certain amount of input value, then it will pass this information. And it's just like any chemical reaction or electrical reaction, a signal is being transferred from one point to the another point, and some sort of some sort of threshold values are set up here, and based on that, if that threshold value get crossed over, then only the input get transferred. If the threshold is not crossed, then obviously the input is not going to transfer. And if this doesn't look like a electrical circuit to you, then I don't know what will look. So let's try to break it down. How does the brain work? How does the information get processed? So as I said, each and information is processed through each and every neuron. So let's say these are the neurons that I have. So what is happening here? So I am receiving the input from these three neurons. I'm receiving the input. It is coming at this point, and then whether this input that I have received, is it going to be passed to these four neurons or not? It is going to dependent on, again, the threshold value. If the input that I have received, it's more than the threshold value or it's equal to the threshold value, then and only then this neuron will pass this input to the other neurons which are connected in series. So as it very clear from the diagram that so it's receiving input in some sort of way. You can see some amount is coming, and maybe let's call it 10. Then there is some unit of input is coming, maybe let's call it 20 or 25, and this is not an input. Let's consider this is not an input. So what do I mean by the amount? What do I mean by amount? As that means, if I say amount, that means some calculation is going on there, and based on that calculation, it is giving me the output. So this amount is called as weights. So based on the weights, based on the input weights that we have, we are able to decide the output. And this was the idea which came into picture in 1943 with Warren McClough and Walter Pitts. That was the idea that they had to build a first neural network, first computational neural network. That how this is going to work. This is going to work on the input, basically input weights, and based on the input weights, if it cross certain threshold, then only the information will pass on. But we haven't talked about, again, the learning. How does the learning happens? Yeah, we've talked about, yes, there is a weight, it get passed on, there is a threshold value. If it crossed, then only that information is passed to the output. But what about the learning? We haven't talked about the learning. So let's look at the learning. How does the learning happens? So let's try to understand that. So learning happens in neural network in such a way that if you are receiving certain weights from single neuron, that is being passed to the other neuron and got processed. So if this process is going to be repeated multiple times, this will strengthen my neuron. This will strengthen the neurons, basically. Strengthen them how? Strengthen them in a way that they can make better calculation. So that's how the learning happens. This was the idea which Donald Hebb gave. He was a Canadian physiologist. This was his idea. Let's try to understand in a very abstract way, how does it work in real life? So let's try to understand. Let's assume that you are trying to learn Japanese. So sorry guys. So let's try to let's assume that you are trying to learn Japanese. So how that is going to work out? So when you speak a Japanese word, some neuron get triggered in your brain, right? And some weight is assigned to the word you said at that point of time. And when for the next time when you are going to say the same word, then the weights are going to update it. The weights are going to update it. What do I mean by updated? I mean they are going to strengthen. How they are going to strengthen? Let's look at it. Let's say you've learned a word of some Japanese, you're trying to tell it to your friend maybe, and you tell it once, maybe you did not you are not able to speak that word in a right way, but next time when you might say that word again, you might have certain improvement in that particular word. And again, if you keep on repeating this process, the strengthening will continue. You will have more strength for that particular word. This, you can take this example to anywhere. Let's say that you are trying to learn a new hobby. So when you go and practice some hobby, maybe you're trying to learn music. So when you go and practice something, maybe you're learning guitar. When you practice guitar for the first time, you don't understand, about the notes, about the strings. They have keynotes, all that information. You don't extract that information in the first place. So that's why what does the teacher do or the trainer do basically? He gives you information basically in batches. He break down the information. He don't provide you all the information in one go. He provide you information in some chunks. You process that information. Once you retain that information, then he provide you some more information. But now that let's assume that you have that particular understanding, now you start practicing. So you are trying to make some music by practicing guitar. So you make a music for the first time, you make a beat for the first time. So you might not able to produce that good quality of beat at that particular point. But next time when you practice, there would be improvements. And again, if you practice, improvements are there. That's why we say practice makes a man perfect, right? If you practice things, you get better. But what is the reasoning behind that? The weights, they get strengthened. If you're solving a problem every day, obviously you'll be perfect in solving that problem. If you're solving a maths problem, a scientific problem, a physical, any problem related to physics or chemistry, anything, so you are very good at that, solving that particular problem, because you've been solving that problem from very long time, and your brain have assigned a very good amount of weight to that particular problem. That means now you have that confidence that yes, if I get this sort of problem, I can solve it. If a new problem comes in, if that is related to the same field, then you will go and give it a try and try to solve it. Maybe if you have seen that information before, then you might be able to solve it. Otherwise you might fail into some difficulties. So yeah, that's how the weights get updated. That's how the strengthening works of the weights. I hope this is clear to everyone. So yeah, this is also clear in this. If this neuron is passing some information and it is triggering this neuron basically, and it is getting triggered. So if this process continues, if it pass information and neuron get triggered multiple times, then these weights are going to strengthen over time. These weights are going to strengthen. They will have more strength over time. So that was the idea that Donald Hebb had, and this gives a more clarity that how can we solve a particular problem, how can we proceed further. Then we said we come up with this word weights. That means we will be assigning some weight when we solve a problem to that particular problem. By weight you can relate it in your real life like importance. We give certain importance certain things in our life when we are solving some problem, or let's not talk about problem, let's say anything. Let's say you are going for gym, maybe you assign some certain weights for that. So weights are going to be different if there is if a person goes to gym daily, and obviously have a higher weightage or a higher importance, that is very important to him. If a person go to temple, church, or maybe mosque or gurudwara, anywhere, right? So he will have certain importance for that particular thing. He will be giving it more important, and he will be avoiding certain thing. If he have to compromise on few things, he will opt that particular thing. So that is again the weightage that we have in our brain that we give to some persons. So that's how it works with the neural networks also. So that means now we understand that there is some system for assigning weights, some strengthening system. That means, are we able to understand our brain fully? That's how our brain works. That is the only way it works. But that is not actually true. There is way more than that. Our brain has sheer more complexity than just assigning weights and updating them and giving some strength. It is way more than that. And we are still in the process of learning that out. But this was the intuition that came into picture in around 1949 by Donald Hebb about the strengthening and the weights. So what exactly we are able to do with this certain task when we are able to assign weights and we are able to strengthen them, we are able to increase their intensity, or we are able to update them. What exactly we are able to do? We are able to solve a problem which we were not able to solve before just by writing if and else statement, that is image recognition. If I see a particular image, certain weights will be assigned to that image in my mind. Next time I see it, my weights will get updated, they will get strengthened. I will start remembering that image. The next time, if you show me the same image multiple times, then that image will get fitted in my system, and I will be able to recognize that image. Even if it is shown to me maybe after a few months, few days, I would be able to recognize it. So that means we can now solve this particular problem. If we understand neural network, we can solve the problem related to the images. Now, how does the learning happens? So there are certain things when we talk about the learning. So there are layers, features, and learning. So that's what we're going to look at. What is layers? What is feature? How does feature extraction work? We haven't talked about feature extraction, feature selection much due to the time constraint that we have, because we didn't get a time to apply a complex problem wherein we have more feature, maybe 80 feature, 50 feature, 20 feature, 30 feature, like the problem related to house price prediction. We didn't have the time for that. But yeah, how does that work? Let's take the analogy first of all. When we try to solve that problem, how does that work out? So we have certain features, so we have to select out of those 80 features, we have to select few of them. We cannot fed 80 of the features or 100 of the features that we have into the model. That is not going to give you a good accuracy. You have to select some features based on some techniques that we have for the feature selection, and then you feed those features into a model, then you get the predictions. So now if I talk about deep learning, this is a hyped word right now, and you might be reading about this, hearing about this word a lot when you go to any of the website, HackerRank, different website, Kaggle, YouTube. There are a lot of videos that are available for it basically. So we will try to break it down how deep learning works basically. Like, and also I guess you all are familiar with this AlphaGo. When Google AlphaGo algorithm beats Lee Seattle, the champion of the particular game, if you guys are aware of, that is also a concept of deep learning, and neural network are being used, and it's a sort of computer vision problem. And then we talk about the self-driving car, that is again a neural network and a computer vision and a deep learning problem which is being solved by understanding the neural networks. Also, when I talk about the Google Translator, which also sings, now you'll say how it sings. Okay, let's see. So I'm just passing in this that I like hot dog because it's not a dog. So do you like hot dog? So I'm converting into Japanese. Just hang on. So what do I mean by sing? It does sing. Okay, let me show you something that might refreshen you. Okay, yeah, I guess that give you some good refresher. So yeah, so how it is different, let's try to understand how deep learning is different from all the other techniques that we have. for the machine learning? How is it different? Yeah, let's try to understand that. So in machine learning, as I was saying that about the feature extraction, we have to select certain feature and we feed those feature into the model, and based on that features, when we have to do all the hard work, we have to take all the hard work to ourselves, we have to select those features, we have to maybe transform those features, we might have to add some values, delete some values, change some values, do multiple things with them, trying to check the correlation, so many things we have to do, and then we select those features based on some of our own analysis. We fed those feature into the model and it gives me the prediction. So that is the kind of learning we call it to be a shallow learning. Now let's see what is deep learning. So what exactly we were trying to do with machine learning? We are trying to find the relationship. If I have this sort of data points, what is the relationship that exists in between them? So it is a linear relationship. In this case, there is a, I have on the side, this is a data set that we have for the housing data set, and in that I have time spent on London Underground, and then the happiness. So I can clearly see there is a linear relationship between that. I also, there could be the case when I have a non-linear relationship, there could be the time at that time. So I have to understand that relationship, then I have to apply the algorithm based on that. Might be some of the time that it could possible that the relationship is more complex, polynomial relationship could be there, or this sort of complex relationship could be there. If I want to separate these two classes, these are two, let's say these are two classes, these are two different objects, if I want to separate them, how can I do? I might have to plot this sort of graph. This is again a machine learning technique with which we are able to achieve that, but we have to code it, we have to change parameters, then we are able to achieve it. But what exactly we do with deep learning? We don't have to do any of it. We don't have to extract the features, we don't have to understand, we don't have to look for whether it's a linear relationship, whether we don't have to look for whether it is a non-linear relationship, whether it is a complex problem, how can I do that, how to transform my features. So that's how deep learning is different from the shallow learning algorithm. So I hope this is clear to everyone. So let's try to understand now how actually this deep learning works, how deep learning solve a particular problem. So let's say I have a model. What exactly we trying to do with the deep learning? I have a model in which I fed my data, which is the data set of certain cats and some non-cats, which could be a dog or something else, but these are not cats. So what I want to do with deep learning, I will fed my data into a particular model that I would have, and what I want to get in output, I want the output as to be tell me that whether this cat that I have fed the data set that I'm feeding, learn from it, extract the features on your own, whatever transformation you want to do that transformation on your own, learn it any way which is possible. And when I'm going to give you an image, when I'm going to do the testing, I need the output. You're going to tell me whether it is a cat or whether it is a dog, and it takes away all the headache from us, that we don't have to do any of the feature extraction or any of the things. That means the computer is going to do all of that with the help of weight assignments and updating the weights and few more things that we might discuss. Yeah, so we might feed to our how the machine, how the model that we are going to build, how it is going to recognize and certain image, is it a cat, is it a dog, so how is it going to be possible. And that means how this is going to be possible only if I feed my system, I feed my machine with lots and lots of images of cats and non-cats, and then it is able to create its own feature. It is able to understand that there are certain things which cats have, and there are certain things which they don't have. It is going to build its own feature, it is going to build its own own understanding. So the way we do, if I show you certain images, I'm not going to tell you that I'm just going to tell you, I am going to give you few images of cats and dog. Look at these images, these are 1,000 images that you have. Look at these images. So next time when I'm going to ask you a question, I'm going to give you a cat image or maybe a dog image. You just have to tell me whether it is a cat or dog. So you will look at those images, you will feed those images in your mind, and then you will try to understand what is the difference between a cat and a dog. You'll have some idea about them and create your own features into your mind, and then next time when you see the image of a cat or dog, you are immediately able to recognize that. So that's how the machine does also. So this is, then it is the, that means, you know, in this case we are not doing anything. We are not doing any coding. We are not writing any for loops. We are not writing any if and else statement. We are not updating the value. We are not writing while statements. We are not appending them. We are not doing tuple unpacking that we have seen in case of machine learning. We are not doing any of that. That work has been taken away by the machine. The machine is going to do all of that. So is it a good thing or is it a bad thing? What do you think? Is it a good thing or a bad thing? It's a good thing. Okay. What about the others? What do you think? It's good. Okay. What, Ajay, what do you think? Is it a good thing or is it a bad thing? When the machine takes away all your work and you don't have to do anything, it saves our effort. Yeah, obviously it saves our effort, but is it a good thing? Okay. Okay. Yeah, it's a good thing. Okay. Let's see. So let's see how does it work? How does it work out? So this is how a neural network is going to look like. That this is how the information is going to be transmitted. Don't get scared if you are scared of this image, that what is happening, what are these lines and all. Don't get scared. I'll try to explain it to you and give you an idea what is exactly happening here. So these are called as my input layers or my input neuron. This is an input layer basically. In this case, this is the input layer in which I have some input neurons which are used to receive information. That means whenever somebody is going to fed some information like images, video feed, or any information, it is going to come in contact with these neurons. These are going to be the first point of contact. Then what they are going to do, the next thing, they are going to pass on this information to every single neuron, the next neuron which they have in the particular chain. And these neurons are called as hidden layer. Hidden layer. This is the hidden layer basically. These are also hidden neurons and hidden layer. This is a hidden layer that we say. So each neuron of the input layer is connected to all the hidden layer inputs. Can you see? This one is connected to this, to this, to this, to this, and this, so on and so forth. So all the permutation and combination has been applied so that we don't miss on any information. We don't make any mistake. That is what we are going to do. So then what happens to it? What is going to happen here? This neuron, which is in the hidden layer, it is going to pass this information to the output layer, which is going to take some decision. Again, all of the hidden neurons will be connected to the output neuron that we have. So now, as I said, output neuron, it will be connected to some of the hidden neuron. That means there is going to be the decision making is going to take place at this particular point. From this point to this point, from this layer to this layer, decision making has to happen at this particular point. How the decision making is going to happen? Let's try to look at that. So this is, we will have a probabilistic function basically, as we say, probabilistic function. What is a probabilistic function? So let's break it down. So that means they are going to give me some probability. They're going to tell me there is a probability that this will be a cat. There is a probability that this will not be a cat, this will be a cat, this will be a cat, this will not be a cat, this will be a cat. So that means out of 6 of them, I'm getting the probability for a cat 4. And I will have a certain threshold value that if the probability is greater than 0.5, that means if the probability is greater than 50%, then I am going to consider that probability only for whichever class it may be. So in this case, I have 4 by 6. So how much 4 by 6? Is it greater than 50 or not? I guess it is greater than 60, right? So that means it is going to give me that particular probability, and it is going to tell me that particular class. If the probability is greater for the cat, I will tell this neuron is going to come and say that it is a cat. If the probability is higher for not a cat, then it is going to come and say this is not a cat, right? Because it is dependent on this output neuron. He is not taking any decision. It's dependent on these neurons. Whatever information he will receive, based on that information he will decide, right? Now how it is going to decide? By using this probabilistic curve. What is this thing is called in mathematics? So this is called activation function. It is going to take some decision. It is going to act on few things. So how it is going to act? Based on, there is a function that we have, just like the function that we seen in case of cost function. In the case of neural network, we have a activation function. So what is that activation function? I have already shown you. It is a probabilistic activation function. It is giving the output in the form of probability. If the probability is above a certain value, then I'm going to assign that answer, that output, to that particular probability which has a higher percentage value, which is more. I hope this is making sense to all of you. If it is not, please ask questions. Is it making sense to you up till this point? Because it might get complicated now. I will not try to make it complicated, but yeah, it could get complicated for someone. So I am hoping that everybody is clear up till this point. Great, it's making sense. Lovely. Now, as I said, this is going to be my input layer, this is going to be my hidden layer, this is going to be my output layer. Information is received at this point, or these neurons will receive that information. They will pass on this information to the hidden layer in all the permutation and combination, and then the output layer, then hidden layer is going to pass that information to the output layer, and the output layer is going to take a decision based on the activation function. But when I say these lines are connected, so what are these lines? These are not only lines. There has to be some meaning to these lines, right? So what exactly these meanings are? Do you remember I said a word, weights? When we do a task, we assign a weights. So these lines which are connected will have certain weights. That means they will have certain importance for these neurons, right? They will pass some information to it with certain weights, some information to this neuron with certain weights, and so on and so forth. So weights are assigned to these particular connection that we have in between the input layer and the hidden layer. And in this case, I have two hidden layers basically. These are two hidden layers. I could have multiple hidden layers. That depends on that's the complexity of my neural network. That depends on the complexity, how complex my neural network is, or how complex my problem is that I need to solve. So based on that, I can have multiple hidden layers. So what is happening here? Some weights are assigned to this connection that we have in between this input layer and this hidden layer, and there is also a connection between one hidden layer to the another hidden layer, and also some weight is assigned to this connection that we have. Then again, certain weights are assigned. That means they think with this much accuracy, or they have this much confidence, you can say, that this is going to be this information that they are passing. They are passing the information, different information to different person. So I could have maybe 3 hidden layers. That is also possible. I could have more layers also, as I said. So what is going to happen? Information is going to come from first input layer, going to be passed with some weights to first hidden layer. Then it is going to go to the second hidden layer with some weights assigned to it. Then it is going to go to the third hidden layer, which will have some sort of weights also assigned to them. Then based on that, it is going to make some decision. So you might be thinking, how does this helps? I mean, how it doesn't make sense. I mean, how we are passing the same information from multiple neurons. Why? How it is helping out to solve a particular problem? Yeah. So it does help basically. That's why we are doing this. Obviously there has to be the reason for it, but yeah, you can think of it as in like there was a person, single person was solving a problem. Now there are two person who are solving that particular problem. Then you have more persons solving that particular problem. So obviously you will have the answer of that particular problem with more accuracy, because that information is now passed into different people. So now you are able to divide task as well. You can say this part of the problem you will be solving, this part of the problem I will be solving, this part of the problem that person will be solving. Now we can do, division of task also. So in this case also you can think of it that way also, that now we are where the task was done by a single hidden layer. Now we've divided that task to two hidden layers. Now we've divided the task to three hidden layers. So obviously it's going to give me more accuracy. I will have better accuracy, right? So now let's try to understand what kind of data is fed into the neurons, right? What is going to be the input of these neurons that I have? What is going to be the input? So let's say I have an image which is going to be a cat image. So that how does that image going to look like? It is going to look in this form. Basically it's going to look in an array. So why it is an array? Because this image have a certain pixels, right? It will have some length, some width and height, and it will have certain pixels. So I guess there are 255 pixels if somebody is not aware. So there are 255 pixels of color. What is pixel? It's the intensity of the color. Basically each color will have certain different picture, pixel, and based on that there are texture developed, there are certain shapes are developed. And at this point basically so basically this image is divided into some parts. You can think of it, there are certain lines that are drawn on this image. Pardon my drawing. So yeah, you can think of it as some parts are drawn, and then there are few numbers which are assigned in between these boxes that we have. Some numbers is here, some number is here, some number is here, some number is here, so on and so on. So what is this number? This is this number which I have here. And why does it have, I mean, three boxes, because it's a RGB image. RGB, which is red, green, blue. So all the images that we see in our real life, they are in RGB. That means it will have 3 dimension. I will talk about this in depth. So let's take it in a very abstract way. That means it will have 3 metrics. So this is the pixel value. The numbers are the pixel value. That is what I was trying to say. The pixel value, it will have a certain value at this particular point. If it has this color, why it has this color? It is due to this pixel value, which is 59. Now if it has some value at this point, why? What is the reason? This due to this pixel value. Then so on and so forth. I hope this makes sense. Yes, they depends on multiple things. They depend on multiple things. Pixel value decide the color. Yes, absolutely. They decide all the things. I mean, the texture that you see, it's all decided on that pixel value. Absolutely. So that means this information for a single image, I have this amount of data, this amount of values that has to be passed to my input layer. So now you can think of how, you can think of how complex this problem is and why we are using neural network to solve this problem. Why not ML? Why not machine learning? Why not we are deciding our own cost function? Why not we are designing our own cost function, updating the weights, giving the weights? See, I'll talk about this also in depth. But yeah, this was a very abstract idea that why not. So let's say I have this image of a giraffe and I'm passing this image in this format to my neural network. So how this is going to take the decision? So let's try to look at in a very abstract way first of all. Then I will try to give you an analogy that you might relate. So as I said, the giraffe the image data is in the form of pixels. It has some pixel value. So that pixel values are sent to these input layers. When they are going to pass this information to the hidden layer, they are going to assign some weights. Let's call them W1, let's call this to be W2, and so on and so forth, W6. In this way also I will have certain weights which will be might be WH1, which is the first hidden layer, so on and so forth, up to WH, how many I have? 6. In this case also H16, yeah. CSV data image, you can apply it to CSV data, but we usually don't do that. With deep learning, you can solve any problem that you can think of, any problem. But we use it for the image data set, for the video feed that we have. That complex problem we'll solve with the deep learning. Image data set, I mean the CSV data can be solved with the help of ML that we have, but we don't prefer to solve that with the deep learning. That's not required. But yeah, if you say, can I do it? Yeah, obviously you can do it. So I will say this is the, yeah, this is 2 now, hidden layer 2. It will have some weights to it, and it is going to be up to, how many are there? 5. Then it will have a hidden layer 3. It will have also certain weights, and then, yeah. So how does that going to work out? So it is going to send information and wait, Kompal, wait. Why are you trying to spoil the suspense? Just wait. I'll give you all that information that you are looking for. Yeah. If you don't get your answer, then you can ask. Just wait. I'm going to come to that point only. Is it going to change or not? Is it going to be same? Yeah. So this information is passed to this hidden neuron, and some weight is assigned to that particular information. Now, maybe it is what information is that? As I said, the data set is an image data set. So what exactly it is going to do? As I said, when we have a complex problem, we divide that problem to different people. So we'll divide, you'll do this, I'll do this, you do this. We divide that task. So how this neuron is going to work out? So maybe this neuron has identified some color intensity in that particular image. So it is going to feed that information. It have identified the feature of a color, that this color is at this particular point, have higher intensity, lower intensity, or something of that sort. They give this information with giving it some weight, that I believe with this much weightage that this could be the reason that it is cat, because it has this much intensity. Now, when this hidden layer receives the color in that information, or all the other information from all the other neuron, because it might think in a different way, it might think in a different way, it might give him some other output. So based on all the input that this hidden layer receive, it is going to create its own feature. So the own feature could be some texture. It might find that there is this texture in this image at this particular point. So could be the reason that it is a cat. And I am sure with certain weightage I'm giving to whatever I'm saying, I'm giving it certain weightage. Due to this texture, this is a cat or whatever it is, right? This is a cat, or I'm giving it some weightage. Now the texture information is passed to this hidden neuron. So they also provide the same information, maybe about something else. Now what this hidden layer does, it creates its own feature. Now they combine all those texture, maybe create something else. Maybe they are able to identify, some portion of the image, maybe the top side, maybe the bottom side, maybe the middle side of the image, and they will say, so with certain accuracy, I believe that this is a cat or this is an image, I give him certain weights. They pass this information to this neuron. Or maybe they created they have understood about the leg, they've understood about the faces, about the eyes or something else, you know. So this neuron then create its own feature, just like all of them created. It will create its own feature. It might say that it has 2 ears, or maybe the ear length is larger, smaller, the legs are in this way. It could create more, you know, features of its own, right? It could think in a different way, and then it is going to pass this information to this output layer with certain weight assigned to it. These, all of them, they are going to pass it. This is going to say that I believe with certain accuracy it is a cat, I believe with certain accuracy it is not a cat, I believe with certain accuracy this is not a cat, and I believe this is not a cat, or maybe a cat. So maybe we have 3 cats, 3 of them are saying it's a cat, and one of them is saying it's not a cat. So what is this is going, what is, you know, this neuron is going to do? In this case, different layers have divided their task. Yeah, they are doing different tasks. Yeah, yes, you can think of it. Yeah, absolutely. So now it has received 3 votes for that it is a cat, and 1 vote that it is not a cat, with certain weights, right? So now what is this output layer is going to do? That is very obvious. Obviously it is going to go with the majority, because most of them are saying it's not a, it is a cat. Obviously it has to say that it's a cat. Okay, it says it's a cat, and then it goes and check whether it's really a cat or not. So it goes and check, is it a cat? No, it's not a cat. It comes back and realize that he had made a wrong decision, what he should do. Then he will tell this information, he will share this information with this, that whatever information you have given me that was wrong, that was not a cat. Maybe you need to think of something else. Now whatever the weight this neuron has provided to the previous information which he passed to this output layer, he is going to update those weights. He is going to change those weights based on, like what we did in case of linear regression. Looking at the output, we made a mistake, we realize that we made a mistake. Just the same thing goes on. We made a prediction, we calculate the error, we try to find out where we went wrong, and then we try to make it better. It is bidirectional in nature. What do you mean by directional in nature? Bidirection, yeah. So yeah, because it is going to come to know at this point now that it is wrong. So it is going to go back and update its weight. It cannot go in this way now, because this know only this person. It has received the information from this person. If you are receiving some information from me, and I have received this information from some other person, that other person have received this information from some other person. So if I am giving you wrong information, and if you know, what you are going to do, you are going to go for that person from which I have received it, the other person have received it, the other person have received it. What you are going to do, Sayyid? Obviously you are going to come to me, because you only know me, you have received the information from me. Maybe you know other as well, but obviously I am the point of contact, right? So you will come to me, you will tell me that this was wrong, right? That the next time when you say things, you need to, you need to think of before you will say this to me, that whatever you said at that point of time, that was not correct. So next time when you say few things with certain accuracy, with certain confidence, you need to check your facts. This is what this is going to do. It is going to update the weights. It is going to update its weight, whatever the weights it has assigned to them. Maybe it increases them, maybe it decreases them. Let's say they decrease, it decreases the weights because it made a wrong prediction. So same way, it is going to tell this one that the information that you gave me, that was wrong. This is not a cat, this is something else. You need to update your information is wrong. So it is going to update its weights also. Same way, this goes for it, this goes for it, so on. This update, they update their weight, and then this information comes to this point. Now it knows that some feature what he have recognized, they were not correct. So maybe you need to recheck few things, you need to look more in depth. So he come up with some new features, he gave this feature with new weights to this one, and then it gives them to this one with new weights, and so on. This process continues. and then we get some prediction. Might be it'll make mistake again. If it makes mistake, it go back, try to correct it, then it comes back, give the prediction again. So this process of going back, updating the weights and trying to get the better accuracy, what is this called? This is called back propagation. We will look into this term more in depth. This is called back propagation. So if you did not understand it, let's take an analogy with which you might understand this. So let's say I am a client and I went to Mark Zuckerberg, the owner of the Facebook, the CEO. So I go to him with a project and I said that I have this image and I want you to recognize and give me the output of that, whether can you build on something that with which we are able to understand that whether this image is of a cat or not. He said, yes, that's fine, we'll be able to do it. So obviously he's not going to sit and write on all the codes. He's going to give the task to his team. Now how the process is going to start? So first of all, he gave this information to this input layer again. So input layer passed this information. Let's call them to be interns. Basically, this information get to the interns. They collected the data and they extracted some information. They sent this information to their seniors or associates basically. So associates also looked at that information. They made their decision. They passed on that information with certain weights. Obviously, the weights has to be there, and with certain confidence, they are saying that this is something what I've understood from it. Then it gets to the the managers or the senior managers. Then they make some decision. They passed on this information maybe to the higher management, to the VPs or to the higher people that we have on the board. So they give this information to Mark with certain accuracy that Mark, I believe this is a cat. I believe this is a cat. I believe this is a cat. And he doesn't say anything. He asks him, why you are not saying? He says that I need more time. I cannot comment anything right now. But they are very confident. They are very confident that it's a cat. So Mark looked at all of their faces and realized that three guys are saying that's a cat. So obviously I had to go with them. I cannot do anything else. I cannot listen to this guy. I don't have much time. So he's going to say this is a cat. He's going to come to me and he's going to say that I've understood your data set and I've realized that it's a cat. And I'll say, no, it's not. Look at this. Does it look like a cat to you? He said, no. How is that even possible? Okay, don't worry, I'll get back to you. I'll get back to you. So what he does, he goes to his office, he called up the meeting, he asks all of his high management people to sit in with him in a meeting and ask them what exactly you guys did. The client is yelling at me. He's saying that I'm inaccurate, I'm incapable of doing tasks. What exactly you guys are doing? So you need to correct yourself, and you need to correct yourself. Whatever analysis you did, you need to revisit that analysis, do something about it. I need the result. I need good results. So after listening to this conversation, they changed their mind that they cannot be right always. They need to think more in a taking consideration a broader perspective. They need to think more and think large maybe. So then they call up another meeting of the senior managers. They yell at them. They tell them that this information which you passed me, based on which what I made the decision, that was not correct. You need to correct yourself. And they yelled at them and so on and so forth. This continues, and then they updated their weights. They realized that they made a mistake and they need to correct it. So they updated their weights, and the managers went to the associates. Associated yelled at them, and associates also realized they made a mistake. They need to update the weight. They were more dependent on these. So yeah, so they went back to the interns. They said, what exactly you did, how you collected the data. You are not able to look at the data in the right way. What exactly you did? So they also updated their weights. Now the interns, they cannot do anything, right? They can only yell at the data, the image data that they have. But yeah, so what they did, they look at the data and they looked at few more things and they found something else. Then based on that, they made their decision. They passed on this information and so on and so forth. This gets updated. The weights get updated every time they made an error. They check how far they were from the actual answer. So then they try to correct themselves. So on and so forth. This continues. The weights get updated all the time, and then they made the predictions. And this process, as I said before, it's called as back propagation. So is it clear to everyone up to this point? Great. So this is how, it's also the same way like we've seen in case of theta. It's also, we are trying to reduce the cost, the error that we are making, we are trying to reduce that error. We want to reach to this particular point maybe where we have the least cost, where the cost stopped changing. Like we have seen, we have not seen this 3D graph, but yeah, we've seen few of things related to that also. So we were trying to reduce the error that we were making, they were trying to reduce the error. So we also have a loss function here. In case just like the gradient descent, we also have a loss function here. So we'll talk about this in depth but let's do one thing. I think we should take a break and then we should proceed further. I guess it was way more for you to process, but yeah, let's take a break and then come back again and then look at it. Okay, if that's okay with everyone, can we take a break? If you have any questions before that, please ask. Any questions you have? Don't. Cool, great. Okay, let's take a break. Yeah, we'll talk about that, Ajay. What data? Obviously, we're going to talk about the image data. Yeah, what about the code, Sunidhi? Codes we use or neural network? Neural network, how are you going to use the neural network? You have to code it, no? There is a code, there is a model for it. Just wait, I will talk about this. First of all, understand the concept, no? Yes, it's important to learn ML. It's very important. You cannot start directly with deep learning. You can obviously try, but yeah, it's recommended that you go for ML first, then deep learning. It's more complex than what we think. Okay, guys, so let's take a break and let's be back by 12:20 and then we'll start. Thank you. Hello, can you hear me? Everybody's back. Can we start? So we can start, right? Okay, cool. Yeah. So we know about this. How does the gradient descent work? So you can think of the same thing is happening here, but it's in a more complex way when we are calculating the error. But yeah, for now you can just think it like the grade. This is just like a grade, another form of gradient descent, which is just minimizing the error. So what we've learned so far is what we have learned so far about the neural network. What exactly is it? Do we know what is happening inside actually? Do we know exactly? Can we change those parameters? Can we change the parameters? Can we manipulate them like the learning rate? And do we know why the neural network is telling it's a cat? No, that's not that way. Okay, I guess you don't get the point. So basically, for us, neural network is just like a black box. We don't really know that why and how it is making those decisions. The example that I gave you, that it is looking at it is recognizing the eyes, the textures, that is just an example. We don't really know whether it is happening that way, whether it is recognizing the edges first, whether it is recognize the center first. We don't really know. We are not really sure of. These are some of the understanding that we have built on, but we are not really sure of. And so it's, what is it? It's just like a black box in which we are feeding some data. It's doing some calculation, giving me the output. But obviously, if somebody wants to understand it, they can, obviously. And there is a whole different branch that we have. There are experts who are there to understand the neural network, to understand how whatever decision they are making, how they are making those decisions, to change the cost function, to change the back propagation. How can we add obviously we can think of that multiple layers and all, but yeah, so there is a whole different branch that we have which deals with the analysis or understanding of the neural network, how neural network works, all the mathematical understanding. They look at that. So now, so far what we have covered, we've talked about the activation function. The activation function is going to help me make my decision, and the back propagation is going to help me in updating my weights. Basically, that's what we have understand so far. So now we've talked about all the glossy advantages that we can solve any problem with neural network. But is there any disadvantages to that using neural network? Is there any disadvantages? Yes, there are. So as I said before, I guess you're not able to see my screen. Yeah. Okay. So I was talking about this. What is the neural network? It's just like a black box to us. And we talked about the activation function, and also we talked about the back propagation. So now we've talked about the advantages. Now let's look at the disadvantages. So when I said it's a black box to us, that means we don't know much about the calculation which are going inside the neural network, how it is updating the weights, with which way, how it is using the activation function, and all the other information. We just have few analogies that we have understood so far, and we are just giving. We are not really clear for that reasoning. If I say that we are not sure why the neural network said it's a cat and why it said it's not a cat, what was the reason for it? We don't really know. So can we use the neural network in everywhere? Yes, you can. I mean, almost everywhere. Not everywhere, almost everywhere. There are few fields wherein you cannot use the neural network, but the question is, would you like to use it? That is the question you have to answer yourself. If you can solve a problem just by using a simple algorithm, just by using simple linear regression, would you go for linear regression? I mean, would you go for linear regression, or would you go for this using any neural network, CNN, RNNs, or the other neural networks that we have? So that is the question that you need to answer to yourself, that if you want to solve a problem the easy way possible, the way that you understand, even if you are getting a lower accuracy, or whether you want to go for a solving a simple problem by complex algorithm which you don't even exactly know. If somebody asks you, so where we cannot use neural network, basically we cannot use neural network in the law making decisions, because obviously we want to know if somebody is granted bail, why it is granted bail, and neural network is never going to tell you why it has granted a bail to that person, why it has given some prison time or some jail time to a person, why, what is the reason for it. It will look at the previous data, analyze it, and looking at the input, it is going to make its decision. It's not going to tell me anything about it. So that means again, if we are not able to use it, then why we've learned about it? And there is all of disadvantages to that. I mean, yeah, the problems are obviously there when we talk about dealing with anything. There are problems always there. So the main problem that comes into picture, the first one is a compute. To solve a problem by using neural network, you need good computing power. And good computing power, I mean very good computing power. Yeah, very good computing power. And the second thing that you need is large amount of data. Large amount of data, that means large amount of data, a huge amount of data, humongous amount of data you need. You don't require 1000 data, you require much more than that. That's what you have to understand, that whether the problem that I'm trying to solve, I can solve it using neural networks, but am I able to collect the large amount of data for it? So let's look at how many parameters we have to deal with. So by parameter, before going to the data, before going to the computation, and understand why there is a lot of computation involved and why do we need large amount of data. Before that, we've seen the yesterday we've tried different parameters. As I said, hyperparameter tuning, we changed the learning rate, we've changed the multiplier, we've changed the step size, we changed the initial step. We were able to get different results. So those were the parameters in case of linear or in case of gradient descent algorithm that we have seen. But in case of artificial neural network that I'm discussing today, what are going to be the number of parameters? How many parameters are actually there? So let's look at that. Let's say I have this particular neural network in which I have 6 input layers, I have 6 hidden layers, I have another 6 hidden layers and 4 hidden layers, and then I have one output, right? So how many parameters are there? Let's try to understand that. So 6 into 6, 6 into 5, 6 into 4, 4 into 1. So how much is equals to? This is equals to 90. That means I have 90 parameters. But can I use this neural network of only 6 input layer for solving a problem of recognizing a cat and a dog? So let's see. So I mean, this was one of the examples basically that I was trying to give you, that basically if you try to, if let's say that your grandma makes a very good cake, and you know about the recipe, that how does she makes a cake, but you go and try to make that particular cake. Yeah, you see that it looks good, I mean it looks very good, and when you taste it, it doesn't look like that. I mean it doesn't look like that. So what you realized, you realize that if you try it again, you might be able to get closer to that, but not, it's not exactly what your grandma used to make. That means you need large time, you need huge time, you need more practice. If you want to practice, if you want to get best at some things, you need to practice it. Might be over time you will understand that she used to cook that or put that in oven at this particular temperature. This is how she used to put sugar, cream, or whatever the recipes she used to follow. Few things might you have to tweak. So in the same way, if we want to make predictions, we have to give our neural network that amount of time. We need to let our neural network practice, make mistakes, learn from the mistake, repeat the mistakes, don't repeat the mistake, solve that problem, and every day make new mistakes, so that It doesn't happen when it sees the data, it is making any mistake. That's what we want to do. We want to, if we want to attain perfection, we have to give it time, obviously, right? And to deal with such sort of parameters every time when it is going to train it, every time it is going to update the weights as well, so on and so forth. So yeah, so now let's come to the data. How much data do I need? So there is a tool, rule 10 basically, that how much data you require. If you have 90 parameters, that means multiply it by 10, and that many parameters you require for your initial modeling. So if I have 90 parameters, that means I require approximately to start off with 900 data points. So you can answer yourself whether you have 900 points to solve that problem or not. Then you can think of whether you should be applying deep learning to it or not. Now, this was a very vague example that I was giving you. Let's consider a real world case. Let's say this is my image. So obviously image will have certain width and certain height and width. So let's say it's a 25 cross 28 image. So that means it has this many pixels, 28 cross 25, and that is, I guess, equals to close to 700. So this is going to be the size of my input layer. My input layer will have this much size. 700 neuron has to be there. And then there will be 6, then there will be 5, 4, then the output. So how much parameter do I need? Do I have at this point? That means I have 4200 parameter for training my model to recognize an image which is of this shape, which is of this size, 25 cross 28. That is the pixel intensity, or you can say that is the size of that particular image. This many pixels this pixel has, 700 pixel it does have. So this many parameters. So how much data do you need? You can multiply that by 10. So that means you require a huge amount of data. 40,000 data points you would require. So obviously, if you have a 40,000, 42,000 data points, then obviously you can fed that data into your model, and then you can get the predictions done. Then the second thing comes to train 42,000 data points and to work on 4,200 parameters every time updating the weights. You can imagine what kind of computing power you would require, how many hours it's going to take to solve or to train your machine learning models. You can just imagine that thing in your mind. So this problem will not be, if you are thinking can be solved with your laptop, with your desktop, then it is not going to be solved with that. You would require a very good machine. So by a very good machine, if you're thinking again, if I have a GPU in my computer, I can solve it. I have a 1080 GPU graphics, GeForce 1080 GPU in my computer. It's a 4 gigabytes of GPU, maybe 8 gigabytes of GPU. So I said we need GPUs, not GPU. It's a plural. We need multiple GPUs to solve the particular problem. And if we go to Google or maybe let's say Amazon and check the price of a GPU, how much is cost GPU that we require to train our model. So let's try to look at that. Yeah. It's something else. Okay, let me see if I can. No, it's close to 11 GB AMP GPU. It's not giving me the pricing. I don't know why, but it is very costly. And even if you have this GPU, which is NVIDIA GTX 2080, it will not solve the problem. Some of the researchers, when they solve a problem related to deep learning, sometimes they use NVIDIA, Tesla. Is it K10 or K80 is there? Yeah, Tesla K80 GPU. This is the GPU which they use, and it's very costly. It's like, if I can find the cost for it. Yeah, NVIDIA 24 gigabytes. So it's close to 60 to 70,000 in India. If I say it's close to 60, 70,000. But if you have that sort of GPU, will that work? That might fail sometime. It happens with the researchers as well, and it is going to take a lots of time. Maybe 6 hours, maybe 7 hours. Sometime it takes 12 hours also. And you can also see, but why it is so costly? Why it is so costly? I mean, like, why? What is the reason for it? And I guess some of you might have heard of the term Bitcoin, because people are buying it a lot to mine Bitcoin. For the Bitcoin mining, they require GPUs if you want to mine Bitcoin. And you can see this is the Tesla stock, I mean the Nvidia stock, just replicating the BTC, the Bitcoin, from quite a long, I mean from few years, from 11 to 2018. I mean it's completely following the trend. And you can also, now you might be thinking that I also have some Google services, some online services like Floyd, Amazon Web Services, Azure, and obviously they are less costlier than rather than buying a GPU. Then yeah, if you have such sort of need, you can always refer to them. But let me be honest about them. It is again very costly. If you are doing it for your personal project, it's going to be very costly. And the the cloud, if I say cloud GPUs, they consume, if they will give you some credits, and maybe for training your model for 10 hours, they might give you credits for 10 hours. It might cost you maybe close to $50 to $100, close to that. And some good offers, I guess, they are going on right now, but it get consumed, that space get consumed very easily. So that means we are not able to solve this problem. Is it that big? Then why we are studying about it? There is no way that we can solve this particular problem. But don't worry, I am here to rescue you. There is something which we have, and always we have Google to rescue us in that case. And here we have Google Colab. So we can use Google Colab. Have anybody out of you heard of Google Colab before? And we can use Google Colab with GPU. Anybody heard of this? Great, Neha. Neha, I've heard of it. Great. So yeah, you can use Google Colab. You can use the Google Colab for training your deep learning model. So what do we do for that? Just type in Google Colab. You will have it right there. Search for it. So it will take you this site, then click on open or new notebook you can create. I already have some notebooks here. It's going to take some time. Then you can connect it with the cloud, and you can do all sort of operation with it. It's just like a Jupyter, because it's built on top of Jupyter. They are using Jupyter functionality. You can add code on it, code something if you want. Yeah. And if you want to use it with GPU, just you can need to go to runtime, then change runtime type. Please everybody do it. I'm not going to repeat it. Runtime, change runtime type, select hardware accelerator, select GPU, and save it. It's getting connected. So once it get connected, yeah, you can use it. Yeah, I guess you did it. So we can use Google Colab if you want to work on any project, if we have our data set with us. And we can do this by going to a drive, then going to file and clicking on more, and collaboratory, we can open it. But when we are going to train our model, as I said, it's going to take long hours. It's going to take a lot of time of yours, and also a large amount of data, and might be you don't get the right weights of that particular model. So what do you do for that? What problem? This is again a problem, you know, that you need a model. Obviously you can have a model, but does that model have right weights? So that is again going to be the problem. Then we have already a zoo for it, in which there are already pre-trained model which are available, and you can go and explore it, which is model zoo, and you can use these models. You don't need to create your own model. You can just go and to this website, and then you can use them. Model zoo, I said. modelzoo.co. So if you go and look for the models, there are lots of models which are available. So YOLO TensorFlow implemented YOLO real time. It's for the object detection with training and actual support for the real timing. Then we have progressive growing GAN and improved quality. So there are lots of advanced models which are already trained there. You can go to them and you can refer to the documentation. Faster RNNs, UNIT, TTS, ESPNet. I mean, there are so many. This website is huge. There are so many, and you just need to import them and use it in your code. You don't have to code them on your own. If you are thinking to code them on your own, I mean, you can surely do that, but just think before you do that. That means you are throwing yourself in a hole if you are thinking of creating it on your own. Okay, so we also have Google TensorFlow, which have it is again a library kind of library which have modules for using the deep learning models like the artificial neural network and the congruent neural network like CNNs. So they are available. We can explore them also. We can use them from those websites. We can install them on they support collaboratory. That is important. Then we have Keras also if we want to use. So let's go to TensorFlow website. If I go to TensorFlow website, so this is what I get. So they also have some common problems solved already for you that you can obviously look at to have a better understanding of the neural networks. So like they have solved this problem of the MNIST data set. It's for the MNIST clothing data set. So yeah, let's try to look at this, what this data set is look like. I'm just going to show you this example. You can obviously go and run it on your Colab. Just click on run in Colab. You'll be able to do that. I will also show you. I have run it. So basically this data set that we have, it's a MNIST fashion data set. So they have MNIST is again an organization which collects data. It's US based. So this data set has close to 70,000 grayscale images of 10 category. Grayscale is basically black and white images they have, because as I said, when we talk about the colored images, RGB come into picture and it becomes more complicated to deal with. So this images, these images show the individual article clothing, and it is in low resolution, 80 cross 28 cross 28. The one that we have seen in the example, that was 25 cross 28, I guess, and it's 28 cross 28. So how many input layer do we need for it? 28 cross 28. It's close to 784. That many input layer we require for this solving this type of problem basically. So MNIST data set by MIT, it's MIT collected by in collaboration with MIT. And how you can load this data set, you can load simply this data set have divided into two parts basically. 60,000 are used to train the network and 10,000 are used to evaluate how accurate the model is doing. So as I said before, that we divide our model into two parts, training and testing. So this is going to be my training data set. I'm going to train my model. I'm going to give it a huge data that it can train. It can learn those weights, and then it can perform very well. So you can see here, this data is being loaded here in the form of MNIST data set. This object is created, and it is available. This data set is available with Keras. So I just have to type keras.dataset.mnist fashion, and yeah, I'll be able to get that data set. Then it is dividing them. It has images. It has an array of images. Then it has some labels. It has test images. It has some labels. It is loading them into different parts basically. So the labels look like this: 0 for t-shirt, 1 for trouser, 2 for pullovers, 3 for dress, coat, and so on and so forth. So I'm creating a class in which name class in which have the name of all of these classes that I have, 10 of these classes. So now what I'm going to do, I'm going to explore this data. So what does my training data set looks like? So my training data set has 60,000 points, and each point is 28 cross 28. Each point is an array of 28 cross 28 basically. The length is obviously 6,000. How does the train label looks like? It has this sort of values from 0 to 9 basically. What is the shape of the test? It has the 10,000 images, 28 cross 28. That means one array of an image have 28 cross 28 images. Now I need to pre-process the images, and I'm trying to show the size, show you the image. How does this image looks like? This is as I said, it's a low pixel image that we can deal with. So you can see the number, it's without grayscale. This is how this pixel looks like. You can see it's starting from 0 going up till 255. That's what I'm saying about the pixel. So it's telling me about the pixel intensity over here. It's telling me about the pixel intensity. This is how it looks like. And what I'm going to do, if I want to convert this image into grayscale, what I will do, I will divide it by 255 because that is the maximum value it can have. So if I did divide it by 255 and then I try to plot it with the help of the plot function by using the subplot, as we have seen, I'm looking for 5 and then I'm using this iteration for loop for here. So this is how it looks like. This is the ankle boot, t-shirt, and so on and so forth. Now the next step comes in building a model basically. So this is my model basically. So model will have different part. This is going to be the sequential, which is going to keep things in a sequence basically. First of all, they are going to flatten the images. What is the flattening? Flattening of the images means the image data set will be like this. It will be 28 cross 28. That means it has 28 rows, it has 28 columns. But that's not how we can fed them into the model. What we have to do, we have to flatten them. By flatten, I mean this. We have to make them one dimensional. We have to make them 28 cross 28 in a single column, and we can have rows close to 786, I guess, 84 or 86, 88 to 64. Yeah, so I can have 270 784. So there are 278 rows that I have in my data set, and this is going to be my input layer, or is going to be my input neuron basically that I will require. So this is what flattening does. Then what is this dense does? Dense is going to create my hidden layer. So I need 128 neurons in my hidden layer. This is what is telling. And the activation function is going to use the ReLU function. So ReLU function is again a probabilistic function. We will not talk about this in detail because that is again going to make a problem. And then in the last layer I have, I have 10 neurons because I have 10 classes. 10 classes I have. So then I will get the intensity or the probability C for one of the classes. All the classes will give me certain probability probability basically. So whichever class will have the higher probability, I will give out the result of that particular class, that this image belong to that particular class. Then to compile the model, I need the loss function, the optimizer, and the matrix. The optimizer is something when we get a loss, we try to update the value, just like we did with the gradient descent. We multiply the gradient descent with the multiplier, subtract its initial position with the and get a new position. So you can think of it that way only. That's what the multiplier does. And loss, calculate the loss, how far we are away from our original value, and the metrics that we are using, it's going to give me the accuracy, how accurate my model is basically. So yeah, I compile my model, then I set my data model.fit. I guess you've seen this. So this was my model basically as a, so I was adding this compile to them, optimizer, Adam optimizer I'm using. Again, there are a lot of optimizer available, but they are choosing Adam optimizer. Then loss function, they are using something cross entropy, and metrics, they are using accuracy metrics. Then they are going to train their model just by passing this command, that is fit train images, label images. When we are training a model, we are providing it both the things, training images as well and labels as well, what these images are referenced to, because that's how it is going to calculate the error. And epochs means, epochs, I guess we've talked about this yesterday. Do you remember epochs, guys? I've talked about this yesterday. Epochs, iteration, absolutely. That means my model is going to run 10 times. Yeah, so you can see here, when the model is running, every time it's giving me some loss, it is having loss close to this point and accuracy of this point, then the loss is reducing, the accuracy is increasing, and at the end I have a loss close to 0.231 and I have an accuracy close to 90%, close to 90%. So what is exactly I am doing, Ajay? I'm showing you example now. First of all, if we will understand this example, then only we'll move to some concept now.
Okay.
Yeah. So what I was doing, okay, where I was, yeah. So I'm getting accuracy close to 90%, 91%, I say. Now what I'm going to do, this is the accuracy I get on the training data, but I need the accuracy on the test data set, right? So now I will pass my test data images and get the answer. So on the test data set, I'm getting accuracy close to 88%, which is really good, and the loss is 0.5%. Then there are a few examples there demonstrating overfitting, preventing overfitting, that we haven't talked about these concepts yet, so I am not going to talk about them now because you might not understand them. So I have implemented the same thing in the Jupyter notebook, and you can also do that. It's very easy. MNIST fashion dataset I've used, so I don't need to, have these files onto my system. I can simply download them with the help of Keras. So what I'm doing here, simply just by typing MNIST is equal to tf.kera dataset, assigning it a variable, train x, train y, hang on, train x, train y, test x, test y. Then I'm loading the data set. I'm dividing it by 255 so that I can scale it to grayscale, and I'm fitting my model. So I'm using sequential. Sequential is something which is, I'm telling my model to keep this in mind. This is going to be my, first you have to do the flattening, then you have to add a dense layer, then you have to draw the dropout. I'll talk about the dropout also. Then you have to do the dense. This is going to be the order, right? So you have to remember this. This is what the sequential function does basically. So flattening, I'm telling it to flatten this array that I have 28 cross 28, make it in a single dimension. Then I'm adding 128 neurons to my hidden layers. Then dropout, basically I'm dropping some value. I'm deleting some values from the hidden layers. I'm not passing those values in because I was getting some error. I was not getting good accuracy when I was feeding all the values. So there are reasons for that. And again, it's going to be little advanced, which you might not get for now. Because okay, I'll give you an analogy for that. Because sometime when your teacher tells you, when your teacher teach you a new concept and he try to give you a problem, so what he try to do, he himself creates an environment that he is doing some mistake, and he want you to correct him at that point of time. He makes some mistake, he deleted some value, he's writing the wrong answer of a problem, and he's just trying to check whether you are aware at that point of time or not. And if you can guess it, that means you have understand the concept. That's what we are trying to do. We are deleting some points, we are not giving it all the points, we are deleting 20% points. That means if I have 100 points, I'm giving only my model 80 points. I'm not telling my model about the rest of the 20 points. I'm hiding them, or I'm dropping them on different levels. So there are different techniques for that, how it is going to drop and all that. That is again a huge discussion. But yeah, you can think of it that I'm not passing 20% data to my model, dropping that data in at some point basically. So I want my model to understand what value should come. I want it to guess those values. I want to randomly generate those values and then give me a better accuracy. Because the reason for that is basically this model, if I will not do the dropout, this model will give me very good accuracy when I'm training the model. But when I'm testing it out with some external images, it's going to give me error. Because now, see what happens is that, again, analogy I'm going to give it to you, might be you relate. If your teacher going to help you solve all the problem in your book, will that give you real intelligence? If your teacher comes in your class and he helps you solving each and every problem in your book that you have, he tells you all the steps, and he hold your hand and tells you solve each and every problem, these are the steps, and he don't let you think that how can you solve the problem, will that build a real intelligence to you? If someday in an exam you encountered a new problem which you never have seen before, will you be able to solve that problem or not? Will you be able to solve that problem or not? That's what we are trying to do with it. Because every time when I'm doing the testing, the data is something new which my model has never seen before. So that is the intelligence that I'm trying to build with my model. I want it to learn it on its own. That's what I'm doing with the dense, or the dropout, sorry. The dense is my last layer, and I'm using a softmax function. Again, it's a function basically. Is again you can think of it, because I have 10 class, so softmax is going to make sure the probability of all those 10 classes lies in between 0 to 1. That's what the function of a softmax. It should not exceed the probability, that it should not give a probability for one class 90%, one for 50%, it's exceeding from 1. I don't want that. I want that probability between 0 to 1. That's what the softmax function does. And I'm using the optimizer, Adam optimizer, again the accuracy. So I was getting the accuracy just by using dropout. I was getting accuracy close to 95%, and the loss was 0.7, which was huge. And then if I go and test it on evaluation is happening, this is the last step, is for the evaluation. I am doing evaluation and fit in the same step. Model fit is happening here, then evaluating, this is the last step, that is evaluation happening. This is my training accuracy. Training accuracy is 97%, training loss is 0.8, and testing, this is the testing accuracy is 97%, and the loss is 0.7, which is amazing. Yeah, so that's about it. I mean, so you have shown same things here, same thing goes for it. It was not giving that good accuracy. I have done the dropout in this 25% dropout, activation function, same function I've used on it. This was another type of data. Yeah, it was giving me accuracy of close to 83%, and the loss was 44. But before that, if I was not using dropout in this case, and I'm using a different optimizer, you might see SGD optimizer. This is again a kind of optimizer. So And in this case, basically the loss was very high. It was coming out to be 4.5 or something when I was not using the dropout, because the model was not learning those weights basically. Yeah, then I made the predictions, and yes, it was able to do that. Yes, predicted ankle, it's an ankle boot. Yeah, it's actual ankle boot. Yeah, it's predicted it's a pullover, it's a pullover. And yeah, so that's how the simplest example of deep learning could be. So do you guys have any questions so far? What we have covered, do you have any questions on that? So everything is clear to everyone, whatever we have studied so far? Is it clear? So should we should we test another few images that I have, or should we keep it for tomorrow? Is it going to be too much for today? Will you be able to grasp that? Should we keep it for tomorrow? Because again, in half an hour that I have, will not be able to cover this. So I think I will give you some time to grasp whatever has been taught to you. I know it was a lot. It was a lot of information bomb that has been dropped. But yeah, we have to do that. I mean, there was no other way to that. And I hope tomorrow you will come up with some questions and we can have a good discussion tomorrow. And then we'll try to train our model, neural nets, pre-trained image classifier we are trying to build. I have some images which are, where is it? Yeah, it's some of these images. So I'm going to fed these images basically. So yeah, I'll tell you tomorrow what exactly I'm trying to achieve by building this classifier. What is the motive and all. We'll discuss that tomorrow. So if you don't have any questions today, do you have any questions for me? Any questions that you want to ask? No questions. Okay, then that's mean we can wrap up the session for today.